Report of the Committee on Historical Basis, Involvements, and Validity of the October 22nd, 1844 Position. Part 5. The Crucifixion Date and Astronomical Soundness of October 22nd. A. The problem and the factor involved. Factor number 1. In archaeological reports, in astronomy, theology, and history, the date of the death year of Christ is a theme frequently discussed. It would appear that no generally accepted authority on the Passion date in either science or theology exists today. Every discussion, however, in both astronomical journals and religious periodicals reaches out for new evidence from the Bible. Early patristic testimony, fragments of ancient calendars on parchment or stone, ecclesiastical records which have survived the centuries are still so wide apart in meaning that it seemed virtually impossible to establish the crucifixion date from the standpoint of history alone. They are related sources upon which constant demand is made by those considering the subject. These include the various calendars of the nations, their standard and local almanacs, the Jewish yearbook and system of keeping time, the ancient boundary stones and tablets with their revealing figures and difficult cuneiform, the dated business contract of Old Babylon, the Assuan papyri, various other ancient manuscripts, the prophecies of Daniel, for almost no chronologist, Eden or Christian, omits Daniel, and above all, the New Testament record of the life of Christ. In the endeavor to fix upon the crucifixion date a year with the Friday Passover in a period consistent with the time of the public ministry of Christ has for some time been the accepted index to the problem. This is the lead followed in the majority of current articles on the date of the crucifixion. But aside from the persistent stand of Catholic writer for April 3, 33 AD, and of the rabbins for a Friday Passover in that year, none of late seem to draw a conclusion without an alternative date. Factor 2. The variety of conclusions offered by these scholars may be charged to three principal causes. A. The location of the Paschal moon in the proper spring month. B. The determination of the true day of the Hebrew first month with which the full moon coincides. And C. The number of Passovers in the ministry of Christ. Factor 3. It should be made perfectly plain that if these two coordinate facts concerning the Passover moon, a position in the zodiac or Mazzaroth, and are placed in the month, are not definitely located and pointed out with accepted authority, no astronomical list of new and full moon dates for the spring months of the suggested years of Christ's ministry can be of any use whatever in deciding this question. Nearly every writer builds his argument upon such a list. However, all these tables of the moon are practically the same, though taken from French, German, or English ephemerides, meaning almanacs. In the quest for solving the prophecies concerning Christ, some of these moon tables go back many centuries, covering 3,000 years or more of time, and marking out the phases of the moon from year to year. The difficulty in calculation does not lie in an error in these dates, which astronomy offers the student of prophecy and chronology, because they are in the main attested and correct. In fact, they can be easily computed and proved from known positions of the moon in our own century by trailing her back through the 100 cycles she has coursed around the Earth since the 1st century AD, from 1930 to 3080, and similar intervals of time. Today we can learn from a standard almanac the moon's position in her orbit, when she is fast and when she is slow, when she is near the Earth, when she is far away, when north of the ecliptic, the apparent course of the sun, and when south. A very same performance has been determined for the 1st century and her position in the sky mapped out in the time of Christ. The difficulty we would emphasize does not lie in a variation of these lunar tables, which astronomy offers to the field of research in the 20th century. Factor number 4. Before the cause of the numerous dates offered for the crucifixion can be understood, for several years, 28 to 35 AD, are by different writers considered possible. The early history of the change from Passover to Easter must be taken note of. Almost contemporaneously, both Jews and Christians were striving to fix their methods of marking time. Because they had been scattered by Rome persecution and could no longer observe the moon and flash their fire signals from mountain to mountain to proclaim the new month, the Jews felt compelled to compute a fixed calendar. The early councils of the Christian Church, convened by the state, were likewise seeking the prerogative of regulating the calendar, which function had formerly been assumed by the ancient Pontifex Maximus of Rome. Mar Samuel of Mar in the 3rd century pioneered a computed calendar for the Jews, and the Council of Nicaea in 325 AD did the same for the Church. In the end, both the Jewish Patriarch and the Pope kept the charge, the one for Jewry and the other for Christendom. But the Ecclesiastical Council of Nicaea dictated a change in the time of the Jewish Passover, upon which the Church wished to build her Easter feast, and to which the scattered Hebrew people ultimately paid homage in the calculation of their almanac. Factor number 5. This change involved placing the earliest Jewish Passover in March instead of April, the limits of the cycle of the Paschal new moons extending even from before the spring equinox to April 5th. But Scaliger, master of chronology of the nations, computes that in the times of the Messiah, the earliest Passover was April 8, and that the latest was May 6. Factor number 6. Another most important feature of the change, one which apparently had not been noticed in connection with the problem of the crucifixion date, related to the command of the Nicene Council that the Passover, which, it should be particularly noted, both Christians and Jews were celebrating, even for 100 years after the apostles, was to be placed on the first Luna 14, after the vernal equinox. These words "on" and "after" make all the difference in the world in the use of the dates of the Jewish Passover moons for deciding the time of the death of Christ. If we accept the testimony of Aristobulus 200 years before Christ, that the Passover of the Jews followed the sunset of the day, when the full moon rising in the east faces the setting sun in the west, we can reasonably conclude that the Jewish Passover, which is repeatedly described in the Bible as the 14th of Nisan or Abib, was the day following the full moon date and not on it. Herein seems to lie the crux of the many assertions which have been offered in regard to the time of the Passion of Christ. Though the modern Hebrew calendar is faithful in a way to the laws of astronomy governing the new moon and her phases, yet no longer does this Talmudic authority recognize the appointed moon of barley harvest for the Passover. Since the destruction of the Second Temple, the biblical sheaf of ripe barley corn has no longer been waved by the priest. Factor number 7. It has been contended by some astronomers and also by certain theologians that one cannot say just how the Jews computed time when Jesus was here, and that their system of calculation was too irregular and too uncertain to be traced with certainty 19 centuries after. Moreover, the influence of Nisan 15 in place of Nisan 14 for the Passover in the Jewish calendar of today is perhaps as equally responsible as is the question of the placement of the full moon date itself for this uncertainty on the part of many scholars, both Hebrew and Christian, in regard to the crucifixion date. These early historical facts and the Jewish calendar features mentioned are closely connected with any solution of the Passion date. Therefore, the attempt is here made to include some of these unsolved questions in the problem to be considered, especially as regards the paschal moon of Nisan, or Abib. A chronological setting should not detract from the spiritual picture of the cross of Christ, if it shows it immovable in time and prophecy. Many scholars are out of agreement as to the length of Christ's ministry and the number of Passovers, but the events and scenes in the Gospel record are so correlated that it seems entirely possible to relate the epochal years of his life to an outline which fits the chronology involved, both from a prophetic and historic viewpoint. As these inspired pictures of Christ are placed side by side, his whole life portrait is redrawn, as it were, and the scenes become harmonious and complete. Suddenly, it is revealed the depth of meaning between prophecy, history, and the science of time. Factor number 8. It is purposed here to show, number 1, that the method of reckoning time used by the Jews in the first century was scientific and harmony with known laws of the moon's behavior. Number 2, that inasmuch as their system was the result of many centuries of observing the moon in seeking from the Jewish mode of reckoning the fact concerning the luni-solar year, we are appealing to the original source of this kind of time and consequently to one of primary authority. B. Timekeeping in the first century. Number 1. The Jerusalem era. The year 170 of the Seleucid era, about 142 or 143 BC, marked the recognition of Jewish independence by Demetrius of the house of Seleucus. Simon, the last of the Maccabean brothers, was then high priest in Jerusalem. In this same year, the people of Israel began to date their document and public instrument according to the year of the high priest, as mentioned in the Apocrypha. Thus, in the first year of Simon, the high priest, the governor and leader of the Jews. This custom evidently continued on down to the time of Luke, who similarly dates the ministry of John the Baptist with joint reference to emperor, governor, and high priest. The Jerusalem era was thus established and has been found engraved on the coins dated the 5th year of Simon's reign. Mathematicians therefore computed for them, the Jews, the cycle, and taught them how to find, by calculation, the conjunctions and the appearance of new moon. Sitowski claims it is probable that these calculations go back much further in point of time. He thinks highly of the happy comment of Scaliger, who several times referred to the method of Jewish reckoning as the most ingenious and the most elegant of all system of chronology. Thus, the Hebrew people came up to the time of Christ with a dated chronological system, a factor of importance in our quest. The Sanhedrin determined each Jewish year by means of astronomical calculations. Although the formula used by the secret council for intercalation has not been found, yet it was referred to by Moses' Maimonides, who said that he possessed it. Mar Samuel of Nardea also had it, and by it computed a Jewish calendar for 60 years to avoid the necessity of double festival days. This he sent to Rabbi Johanan in Jerusalem as proof of his knowledge. It was Hillel too who, in the 4th century, passed the secret on to the other world, and so it became the basis of the modern Jewish calendar. The Jew doubtless had known the length of the year from Egyptian times, but their method of intercalation was different on account of their Passover feast. This they regulated by the maturity of the barley. Moses commanded that they should not even reap their barley until the first fruits of it had been offered to the Lord at the time of the Passover. Siruski adds, the aim of the Mosaic command was to regulate the months according to the course of the moon, and the whole year in accordance with the course of the sun, by assigning as a starting point the lunar month coinciding with the beginning of a determined solar season. That determined solar season was still the barley harvest in the time of Christ. Later on, as after the dispersion of the Jews, the Sanhedrin did not content itself to observe the maturity of the barley, but added what we know today to it, the observation and calculation of the equinox. The ceremony of the barley harvest was the divine rule by which the position of the Mount Nisan was located, or Abib. It was by the 1st of Nisan, if by the 1st of Nisan or Nisan the barley was not sufficiently advanced for the Passover festival, then a leap month was added, and the feast period of the year was delayed until the following month. The Lord had promised Israel, when he ordained the Passover, that he would send rain in due season in order that the corn should be reaped in time for the feast. On account of this ceremony, a special field of barley for the temple was sown in the sheltered Ash Valley across the Kidron. Such a provision as the barley harvest control of the year thrusts definite certainty into Jewish reckoning in the time of Christ, one which held until the Jews were scattered after the destruction of Jerusalem. By this rule, we know that the Nisan Paschal moon could not come until the rains were over and the barley ripe. On these two counts, a Passover in Distrius, the ancient name for March, is out. For all the reports on agriculture and meteorology in Palestine, ancient and modern, show that March is the month for the latter rain, and that barley ripens in April. The Hebrew Paschal song included this refrain, "The rain is over and gone." Consequently, as regard the astronomical element that enters into the date of the crucifixion, one should look into the ephemeris for Passover moons in April and not in March. Scaliger says that in the time of Christ, the Paschal moon limits were April 8 to May 6. He showed that those who later used the Dionysian moon table thought that they were celebrating the Jewish Passover in Nisan when it was 10 times in Adar during the cycle of 19 years. He learned this, he said, from the Jews themselves, which that would have been what we call today the embollismic year instead of the common year. Another feature pertaining to Jewish reckoning in the 1st century concerns the day itself upon which the new year was started. The Jews, Arabs, Chaldeans, and Damascenes all held had the same custom in reference to the beginning of their month. They started the new month with the first appearance of the new moon after conjunction. The presence of the moon in the western sky at sunset was called a phasis and marked the following day as the first of the new month. This period from conjunction to phasis Hevelius called the interlunary period, which Scaliger called it the translation of the moon. In this discussion, in part 5, the term translation is used in the sense that it refers to the time between conjunction and the sunset, marking the beginning of a new month, the sunset near to which the phasis always occurs. The Jewish new moon, that is, the new moon that marked the first day of the month, commonly exceeded the ordinary size of the phasis or first appearance of the moon. This was in the case of the Hebrew people. While the Greeks started their month from the conjunction itself, it was a certain shape of the moon that regulated the beginning of the month, the Jewish month or Hebrew month. Scaliger sometimes called it the horned moon. Rabban Gamaliel, chief of the Sanhedrin in the middle of the 1st century, had pictures of the moon on a tablet on the wall of his upper chamber. By means of this chart, he examined the witnesses who had observed the moon and would ask, "Did thou see the moon on this wise or that?" In Jerusalem was a large courtyard where the witnesses were examined by the Beth Din. They were questioned. "Say, in what position did you see the moon? In front of the sun, meaning to the east of it, or behind it? To the north of it, or the south? What was its elevation on the horizon? To which side was its inclination? What was the width of the desk?" The accompanying illustration makes a little plainer the meaning of the question asked, which after all were truly scientific. So here we have the horn crescent, wider and higher, older, farther east. This is the first visible crescent. And of course we have the ecliptic, which is the line on which the sun and the planet travels every year. We have the line of the equator for the Earth. And again, the young moon on her back east of the sun. That would be the young moon here. Then we have the sunset and the horizon. And we read, "In the spring, because of the steep ecliptic, the crescent moon is level with the horizon. With very young moons, it looks like a very fine bright thread from left to right," like this one here. This is the horn crescent. Looking for the young new moon, which is as fine as a thread, I would believe for a moment that such a colored horizon stripe was the crescent, and have exclaimed, "I have it," only to see a minute later that I had been mistaken, because the thread disappeared or divided itself. This was from November 1927. Now we continue. Hevelius fully describes the horn moon and designates when the moon appeared as such. This will be further demonstrated as we continue. Sidusky says the calculation of the conjunction was known in the course of the last centuries preceding the Christian era by calculating this visibility in advance by means of inductive methods established by the ancients in consequence of observations over centuries. The very nature of these questions show the extent of the astronomical knowledge which the Sanhedrin possessed concerning the moon's phases. The historical testimony is obviously true that this tribunal had in hand the calculations pertaining to the moon's position and her translation at the time of the new moon. These observations were continued even long after the knowledge of astronomy made it possible to calculate the date of the new moon in advance, at least a century before the time of Christ. The deliberations of the Sanhedrin always took place behind closed doors, thus surrounding with mystery their secret council called the Sod Abor. And this, of course, was before the temple was destroyed in 70 AD. The questions asked the Hebrew observer in the 1st century AD involved the same principle as used today in computing the common almanac. How wide was she? Inquired Rabbi Gamaliel. So it is that the width of the moon from horn to horn determine a position in relation to the earth. The relatively widest moon is nearest the earth, that is in perigee. The least wide moon is further off or in apogee, both from horn to horn, which the first visible does not have horn like that. The witnesses reported how near the sun was to the moon and how low on the horizon. The altitude of the moon above the horizon and her distance from the sun at sunset indicate, in a general way, the moon's age, namely how many hours have elapsed since conjunction. The older she is, the later she sets after the sun. The proclamation of the new moons by the Sanhedrin constituted one of the strongest elements of cohesion among the Jews and was jealously guarded as a general prerogative of Palestine. Rabbi Gamaliel said that he knew the value of the synodic month from his grandfather Hillel the Babylonian, and in the Megillat Tinet, we have the first complete enumeration of the Jewish months in their order, which, according to Schwab, must have been written and introduced about 6 or 7 AD. The Palestinians, Jews of the 1st century kept their calculation based on the true conjunction and phasis, in contrast to which the Jews of Babylon and those under Babylonian influence in the time of Hillel, 359 AD, computed their calendar on the moled or mean conjunction. There may be, however, as much as 14 hours difference between these two conjunctions. The significance of this fact must not be overlooked as a most important feature of Jewish time or Hebrew time in the 1st century. Those were the Hebrew or the Jew of Jerusalem, not from Babylon. For in the study of the dates pertaining to the years of Christ's ministry, we are dealing entirely with the true astronomical moon as employed by the Palestinian Jew and not with the fictitious moon of any cycle, as is the basis of the Catholic Church collect and of the modern calendar of the Jews. After 1,500 years of experience, the Jewish Sanhedrin were well versed in the science of reckoning time. The famous treatise of Maimonides, philosopher and Hebrew sage of the 13th century, is perhaps our best example of the ancient Jewish astronomy, which became his later heritage. He claimed that his formulas of computation of the moon phases has long been known to the Jews, and that they used these calculations as a check on the testimony of the witnesses. An identical method is still used by the Karaite scholars for making up their calendar as described by Koki Sof. Thus, the translation of the moon or calculation which determines the first day of each new month is perhaps the most complex feature of the three involved in connection with Jewish timekeeping in the 1st century, which are 1. A dated era, 2. A festival ritual governing the position of the Paschal month, and 3. The translation of the moon marking the first day of each month. From the day of Ezra and Nehemiah to the present time, a long series of historical and astronomical source materials now offer a complete picture of the new moon and her phases. Every detail of her performance is described either on tablets, stone, or parchment, or in books of ancient and modern astronomy. Thus, as the way being prepared for effective chronological study with reference to Jewish luni-solar time and its bearing upon the death year of Christ. Any reasoning that Jewish time in the 1st century was based on a plan so irregular and secret that it is now impossible to lay bare the system is not at all in harmony with the facts. The historical records and the custom and ceremony connected with the Jewish form of year are fully recognized and understood by both Hebrew and Christian scholars and may not be ignored. And we always encourage you, of course, to read the references which add a lot to the knowledge, especially in this Part 5 series of our study. So we know that the Jews had been committed through the prophet Daniel a long series of time prophecies relating to the principal nations of earth, recognized by both Oriental and modern chronology as important, and definitely dependent for orientation upon a stable system of common time. This has been provided for us in the blending of Jewish and Roman timekeeping. Both Julius Caesar and Augustus did their part in regulating the civil calendar of Rome, while the Jerusalem era proved to be a stable epoch in timekeeping. Each day of those years has a definite number in the universally accepted Julian day numbering. Number 2, the Julian calendar. In modern times, civilization largely follows the Gregorian calendar, which originated in 1582 AD. From the 1st century on to the days of Gregory XIII in 1582, dates are commonly recorded in Julian time. Every day in each week of this long period of time has a designated number in Scaliger Julian day reckoning. And this is actually very, very seriously important in order for us to be able to convert, like we do today, from the Hebrew calendar to the Gregorian calendar. At the time of the Julian calendar, there was a technique, a way of converting also the Julian calendar with the Hebrew calendar, and it is not to be rejected. This system offers a simple but absolute method for determining the feria, or day of the week, for any given date in the time of Christ. Scaliger carried his number back to a point many centuries before Christ, his 0 number ending on a Monday. Every Julian day number, therefore, represents a certain number of weeks with a remainder. These remainders correspond to the days of the week according to Schramm tables. So the remainders would be 0, 1, 2, 3, 4, 5, 6, and the feria, or the day of the week, would be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, as we know them today, the planetary week as they're called. And this table is found in any late American ephemeris or almanac. The Julian day table have been called the Astronomer's Bible, so universally have they been adopted in astronomical circle. They are important because the Julian calendar was the Roman calendar, and you can convert it in order to have the exact conversion to show the true date of the Hebrew calendar for that time. In other words, since the Julian day numbers ended with Monday, any remainder of a number after the weeks are taken out will represent just so many days this side of that first Monday. If there is no remainder, then the number itself represents Monday. For example, to find the day of the week for April 27, 31 AD, its Julian day number is, according to the one who has put it together as we saw, 1732497. Taking out the weeks by dividing by 7, we have 4 days left. Add these 4 days to Monday and we get Friday. So Monday, Tuesday, Wednesday, Thursday, Friday. So you take Monday and you add those 4 days left, you come to Friday. It's a very simple method that can actually be used in order to convert and to see the relation with the Hebrew calendar. If one does not have access to the American ephemeris or almanac, a simple table may be made for the 1st century date as follows. January 1 AD, Julian time was Saturday. By reckoning forward from this point to the year 31 AD, observing the leap years, January 1 will be found to be Monday for that year, and from Monday inclusive, add the 117 days reaching to April 27, and we similarly, get Friday. This is for AD1. Every day has been astronomically numbered as far back as history goes. No feria or day of the weekly cycle has ever been added or dropped. The first century was not only true to the days of the week, but the Julian calendar was of such a nature that the seasons came at the proper time of year, in contrast to the Egyptian calendar, whose feast days wandered through all the season because its years was too short. And this is why we have the Gregorian calendar. This was when the Julian calendar was just set up, but over the centuries, when we come to 1582, by then the Julian calendar had wandered away. Being a solar calendar, it had wandered away from the lunar calendar, the lunar cycle, we could say. So therefore, that's why Gregorian calendar was set up by Gregory XIII in order to make up for that difference with the cycle between the moon and the sun. This section was prepared by Grace Amadon.